go. Aman, by the way, the class has been like like gone a bit early. Okay, like 10 minutes early. Anyway,
Yeah, got it.
all right. So now we're gonna start with rectification. Rectification is a very very important topic, and this is mostly in this chapter. This will come. So rectification is the process that ensures current flows in only one direction using a diode or combination of diodes. All right, now so what you need to understand is that normally if you test out AC supply, so AC supply would look like something like this. Okay, so here we have the voltage, that's the time, and that's when you actually have an AC source which is connected to a resistor maybe, and that resistor is connected to a CRO. All right, so the CRO is displaying this wave, which means that this is like this portion is the half cycle. Half cycle means that this is till when it just goes up and down, and then this portion is the other half, right? So it changes the direction every halfway for a full wave, right? Like that. And this is the first signal of AC. Now, what rectification does is that we generally would want it to flow in one direction. That's what you have learned in O levels as well, like IGs. And to do that, we would connect a diode, and then we would connect a resistor. And by doing so, if we would have put a CRO, the CRO would have shown us something like this. So it would basically cause, like it would cancel out everything on the other side. So you would have like this side intact, let the current flow, but the other side, which should have been here, is just cut off, right? So this is basically, I would say, that's the, for half the cycle, this is half cycle, it's the same, but for the rest half, like from here, it's just cut off. Is it clear? Now this sort of rectification is basically termed as half wave rectification. And the reason this basically rectifies only half, the worst part about this is that 50% of energy is wasted. So it's not a very good way of doing it. And how diode does this, because a diode in reverse bias diodes have a very high resistance. In fact, instead of writing resistance, let's write impedance. And then in forward bias means that when it's going this way, this is forward and this is like reverse. In forward bias, they have almost zero impedance. Means very, very less resistance. Alright? That's why you see that half of it is like wasted, and we don't like that at all. So we got to do something about it to basically make sure that there is full wave that we can get eventually. So you guys have drawn this. If you have any questions, let me know. Okay. What we aim to achieve is, we aim to achieve a full wave rectification. That's what we need. A full wave rectification means that, I'll just copy the upper one. I want to draw it again and again. So full wave rectification would mean that when I'm drawing, like I'm getting this wave, making it go in a single direction, I should not lose anything. In fact, I should be getting the part that was wasted back again, like that. So it means not only somehow I would have this all the time though, but I also want this section to come back to me as well. That's just the half. So then when we both have them, like we both basically achieve to get them back, this is basically now a full wave rectified voltage. Is it clear, everybody? Any questions up till here? Right. Now, I just want you to know that what I'm trying to basically do here, this can only be achieved by a wheat stone bridge rectifier circuit. So in this circuit, we generally have like couple of diodes which are arranged in such a way that none of the energy is wasted. Alright, but before we go into that and the design of that we of course need to do, we would like to learn about some of the rules that it follows so that we have the idea that what we're really doing. So number one, the current can only flow from higher potential to a lower potential. That's how always the current flows, right? So because it goes from positive to negative, from higher to lower, that's how it does. Then the second point you should remember is that across each electrical component there is a potential drop. Potential drop means that of course some of the uh, electrical potential energy is going to be used by that. By use means converted to other forms. So of course the overall energy per unit charge is going to drop a bit when the current flows through it, like that. Okay. Now the third, a diode is forward biased. Okay, you need to remember that. If potential behind the diode is greater than the potential in front of it. What I mean by this is, like for example, if you have this diode placed, and here you have potential V1 and here you have potential VB, V2, okay, and if V1 is greater than V2, then of course the current is gonna go like this. Okay, so it doesn't matter, so it will let it flow. However, a diode is reversed biased, okay, if the potential behind the diode is less than the potential in front of diode, which means that if this is your diode and here you have V1 and V2, but this time V1 is less than V2, then the current will not be able to flow. Is it clear, everybody?
Sir, could you scroll up a little bit?
Yes, why not?
Sir, more, sir, पिछली diagram देखनी है.
Here?
Yes, sir, that's it.
Acha, okay, fine. While you guys are at it, I should better do something. You copy something.
Sir, could you explain again what it's meant by impedance?
Just the resistance.
Oh, okay, sir. Done, sir, thank you.
Okay. Just give me 1 minute. You guys can copy this till I'm doing my copying. Can't draw that diagram again and again. Okay. Done, everybody? Should we go forward then? Okay. Great. So now I just want to show you how the bridge rectifier basically looks. It looks like this, okay? Alright, so do not worry, do not get scared. It's pretty simple, normal thing. You learn in a bit what it means. So you got A, B, C, D diodes. One thing I want you to tell you is that whenever you see this bridge rectifier, the diodes which are exactly opposite of each other are parallel, and then like you see in the same direction like this. The parallel diodes are the same direction. So you can always remember when they ask you to make the diodes. Usually they will ask you to make the diode if they're not asking anything else. Okay. So here we have an alternating supply where CR1 is connected, and then one CR3 is connected across a diode, and when CR2 is connected across the resistor. Alright. So let's talk about when this becomes positive and this stays negative. For that instance, what happens is the current is gonna go from here, and then it's gonna go from here. So I would recommend that in your exam you should take two color markers, okay, or colored pencils, so you can also rub it off. So when it reaches point 2, then it got to decide where to go, because D is the reverse bias diode, so there's no other way for it to go than this one. It goes like this, and then it allows it to go because it's forward biased. And now at 3 it can't go back to B. The reason is that it's reverse biased here, so it is basically forced to go here, and from here it goes through R and then Y, and then from here it just goes in a straight line till here, and then it turns following the path. So when it reaches here, now it can go towards like D and C both, but it chooses to go towards C because in the third point that we wrote, in the third and fourth point, we know that the potential at 2 was higher than the potential at 1 because the current has made a drop, like because of it has moved through diode A, and it also has moved through the resistor. So because of the potential at 2 is higher than 1, so it will go towards 4 then. It won't go towards that. Go here towards the 4, and then it will go here, here, and finally it will reach back to M. Do you guys understand the path?
So can you explain again?
Like if you see from L to 2 it can go straight, right? There's no other way. When it reaches 2, either it has a choice to go towards D or diode A. D is like the diode that's connected in the opposite direction, so it can't go there, so it has to go through A, right? At 2.
Yes, sir.
When it reaches 3, now again it can go towards X or B, but it won't go towards B because that's the diode is like in the opposite direction, alright? So it will then go towards X, and from X it will drop, it will give some energy to R. So there will be a potential drop, and it will go from X to Y. And from Y it reaches 1 again. Do you see? Because there's no other path, right?
Yes, sir.
Now the interesting thing is that when it reaches at 1, because it has gone through all the circuit, it has lost some potential of its own, right? Because of the R. R took some of its energy away. Understood?
Yes, sir.
So although now it can go towards D, because it's also in the same, like in the forward direction and C. But it can't go towards D because the potential at 2, which is the start of the circuit, is higher than the potential at 1. So current can't flow from low to high, it will always flow from high to low. Do you get my point? So then
Yes, right.
it will turn towards 4 and get back to M, which is the negative terminal right now. Understood?
Yes.
So now on the graph on CRO1, you have 1/2 cycle completed like this. And this one also CRO2 is against CRO2 also one. CRO2 is the one against R. So 1/2 cycle has been completed, and CRO3 and CR2 1/2 cycle is completed because the current moved. However, when the poles basically just switch, so this becomes positive and this becomes negative, then of course it will move from positive towards the negative, so it will go like this. And now we're following the blue path. So when it reaches 4, it can't go towards C because it's in the opposite direction. So it has to go through B. And when it reaches 3, it can't go to A because it is on the opposite direction. So it has to go to X then. And from X, it will go through R. And if you notice something interesting, you see, although the direction in the start right here, you see the red and blue current were in opposite directions. You get it? But when it reached resistor, they both have the same directions. So we actually played around with it and had to move through the same direction. You get my point? So now it will go towards, like it has gone here. Okay, could have simply undo. So it has gone there. Now it will go right here, and from here it will turn this way, and it will go this way. Now when it reaches 1, it can't go back to 4 because 4 was the start of the circuit for blue current. So the 4 has greater potential because now when it reached 1, it has some potential drop through R. So it will now be forced to move towards D, and when it crosses D, now again it can't go towards that because of higher potential, so it will turn back, and now it will reach the negative side of it like this. You get my point? So the CR1 that you see is basically monitoring that it goes like in the opposite direction, like you can see blue and red are opposite. CRO3 does not show anything after half cycle because only red current goes through that, never blue, so that's how it is. But CRO2, basically both currents in the same direction, so it also shows blue in the same direction, so it has been fully rectified. Do you understand? Okay, when the meeting ends, please rejoin, alright? Anything you would like to ask before I start writing about it? Ramin, Suman, Gatika, Aman, everybody understands this?
Yes, sir.
Okay, now let's move forward. So I'm gonna write about the first half cycle in red, and I'm doing this because I want you to remember this, alright, with all the same things. You can, you if you've drawn this, that's fine. Just make sure that you've put this right symbols and numbers so that when you're following what I'm writing, you can remember. Okay, so first of all, when L terminal was positive and M was negative, basically the current went to junction 2. You can basically follow along the diagrams. It went to junction 2, and from junction 2 it had then gone via diode A, and I'm just writing not D because it's reverse biased. Okay, you can check it on the diagram as well. Then from here it had gone to junction 3, and from junction 3 it has gone from X to Y via resistor R, and then it has gone to junction 1 and via diode C. Not D because potential behind diode is less than potential in front of it. Hence, it acts as reverse biased, like that. Okay, and then it goes to junction 4, and from junction 4 back to terminal M that is negative. Do you guys understand this path? You can look at the drawing and you will be able to trace the line that way. Okay, so for the blue current, I'm going to write a second half cycle, and for the second half cycle I'm saying this is okay, sorry. All right, so second half cycle is when the current switches. So this is when after direction of current is switched, so L becomes negative and M becomes positive. So then it needs to go towards junction 4 first, and from junction 4 it will go towards, write it here, via diode B and not C because it is reverse biased, and then it goes to junction 3, and from X to Y via resistor R, so it's the same direction, and from here it goes to junction 1, and from junction 1 it basically goes via diode D and not C, because potential behind the diode is less than in front of it. Hence, it acts as reverse biased, like that. Okay. And then what happens is that it goes to junction 2, and from junction 2 it goes back to the terminal L negative. Alright, now I hope you guys understand this. If you still have any questions, anything you'd like to ask, please let me know so I can help you with that. Okay. Okay. Ramin, it is clear, right?
Yes, sir.
Okay, that's pretty good. So the thing is that usually in these sort of questions, they are going to test your knowledge about the movement of the current, because now that you've learned how the path follows, and sometimes they will also ask you to draw the direction of diodes, the correct direction, by just drawing them on the diagram. So if you've written it, I can show you some of the questions so you guys know what you should be expecting from this. Okay. Fine. All right, so let's see some of the questions. Like to is my topical. Okay, it's here. So we are going to look at alternating current 517. Okay, this is a simple thing. We are not going to get into it right now. Okay, this sort of question that I'm talking about. So first of all, in this question, you should realize that, okay, this is like transformers are not there, but suppose this was like connected from here to here directly, and there's nothing like this. They've said draw the symbol of 4 diodes to produce the polarity across the load shown. So they say there should be a positive, like higher potential here, lower potential here, which means that no matter which type of current, whether the half cycle should also go here and the other half should also go here. Do you understand my point? So now I would just pick one of them. Like I would say, okay, let's draw red. So if you're drawing red, you could say, okay, the current comes out from here. It goes like here. So I want this current to go to this direction, like this direction, and then it should move like this. In fact, I had to draw this like this, sorry. Go here, and then it should go here, and then it should be forced to go here. If I want this path, then I have to draw a diode that should look like this. Is it clear? And naturally, then this diode should be in the opposite direction so that the current doesn't flow here. Okay. Now I told you the trick that the diodes in parallel diodes have the same direction. Like this would be like this, and this should be like this. It could be different than what we have drawn already in our notes, so that doesn't matter. So it should go here, and then it should go here, and then it should go back to this. And we can test it out by drawing the other one as well, whether it works or not. So I'm going to go from here this time, and when I reach here, it should go here because that's reverse. It is going here, here, it's going here, fine, and then it is going this way. It can't go here and that. So this should be the way it should be. Do you guys understand this? So that's how they
So how
went.
did you know both the red and blue arrow would come down
Because
initially?
because if you look at the diagram, they've given a positive symbol here, negative here, which means the current should flow this way. You get my point?
Okay, yeah.
They've already fixed it. So that's why I knew that I have to put diodes in such a way that they push the current in this direction.
Both of them.
Yeah. So even if you get the first one right, you get the first one, like I have gotten the first one. I did not know any of these, right? I just knew that when the current is like moving, when the current needs to go like from this direction to this direction, it must be forced here and then it should go here, right? So to make sure that it doesn't go this way, I have to put a diode as reversed biased here. Do you understand?
Yes, sir.
And when I got to know these, I know the parallel ones have to be the same way. So you see the parallel are in the same directions. Understood? And
Yes, sir.
it just gives me the answer. I did the blue one just to recheck whether it does go through the same path or not that I need. So it's pretty simple. It's just that you just need to, sort of put barriers and guides for the current to go in the right direction. So it's kind of fun like that way. Understood? Alright, so I guess I will see you people in the next class then. Have a nice day. Bye.